Hello everyone, Lisa Cronin is my name. I'd like to say a particular hello to Alan and Pat. They're on the Sligo Rivers Trust, and I'm a member of the Sligo Rivers Trust myself. My own area of interest is in water quality, particularly surface waters, rivers, lakes, and drinking waters. So if people do have any questions, we're going to do a question and answer session at the end. That won't be recorded. It just gives people that opportunity to ask questions in the forum that they're in. While I'm certainly not the oracle and I don't know everything, anything that I don't know and that you particularly want to find out, if I don't have the information here, then we'll find it for you and get that to you afterwards. I suppose just to start off and to some of the context around this in terms of our global water resources, okay? So the amount of water on Earth is the same, okay? It's always been the same, it's still the same, okay? It's in a permanent circulation and regeneration. Also, just to mention, I've sent these slides to Caroline, so you don't have to take notes, particularly if you don't want to. And I have more slides here than I'll be going through this evening as well. So I'll be flying through some of these, but I suppose it's just to put it into context. So over 97% of the water on the planet is salty water, okay? 2.5% of that is fresh water. And really, a lot of that then is tied up in glaciers and permanent snow cover, which of course we're losing with the changes in our climate. So roughly about 0.5% is easily accessible for human use. And we're very fortunate in Ireland and across the water as well in the UK that, we're water-rich countries, okay? We've a lot of water and we've a lot of water resources, and we're very fortunate in that, okay? So in terms of global threats, then, of course, we all know about climate change, depletion of aquifers. So we're seeing an increase in our population, we're seeing an increase in our water use. And then, of course, there's that whole challenge around pollution and contamination, okay? So global water scarcity is increasing. This is just a chart from the Irish water utility, Irish Water, and it was just a regional demand report from June 2018 when we had one of our heat waves that don't come too often, but when they do, they really hit us. And that's one of the disadvantages of being a water wealthy country. You're not ready really for those droughts. And it just shows the water production is actually the blue line, and the total storage is the red line. And what they found started to happen as the rainfall started to become less was that the gap between the amount of water producing and the storage that we have in the system becomes less. We can see that very obviously in reservoirs like this because they're tracking that all the time. But of course, that's also what happens in our natural environment as well. Okay, so during intense, when we get these heat waves, and of course, they would have seen them in London and other parts of the UK as well. The demand for water goes up. People start washing their cars, filling paddling pools, and all that sort of thing. And our ability to meet that demand, both in terms of the infrastructure, in terms of water treatment, is challenged, but also environmentally, and to meet what they call environmental flows. So all of the fish and the other organisms that live in our waterways need minimum amounts of water, what they call environmental flow. And these climate change threats and changes in our weather patterns put a lot of stress on that. Okay, so water scarcity, and there's physical water scarcity where you don't have enough water, and then there's economic water scarcity. And economic water scarcity is very often where you have the water, but you don't have the capability of abstracting it. Maybe you don't have the engineering provision, or maybe there's a lot of corruption, or maybe there's a lot of water theft and things like that going on. Some interesting statistics: 93% of Africa have access to a mobile phone. 63% of people have access to piped water. So it's really interesting in terms of how some areas of our lives technology has marched much further ahead. As I said, global water consumption is on the way up. And that's very much collated to increase in standards of living. Okay, so as standards of living go up, our water consumption goes up. And that's particularly problematic in countries where they're water wealthy, like in Ireland, because we don't value water in the same way because it's everywhere. Or our perception of it is that it's everywhere. You've probably all seen this chart before in terms of the natural water cycle. So you've got that constant cycle of evaporation, condensation, precipitation, and groundwater. And what's interesting here is the urban water cycle then. And one of the big problems with the urban water cycle is we've actually interfered with the natural water cycle. Okay, so we still have evaporation happening, condensation, but we get much less infiltration. Okay, so we're getting much less water filtering down to the ground and into our aquifers. So we're starting to get lower groundwater flows. We've much higher levels of paved areas, roofs, roads, paths, and all of that. So we've a lot more runoff. So we have a lot more direct pathways, what they call direct pathways from our urban landscape to our rivers, our lakes, and our groundwaters. And that's a problem for a number of reasons, in that you have water moving far too quickly, which is why we end up with flooding happening. The more paved areas we have, the faster the floods will flow. And you've got much more water going much more quickly into that. And of course, we always have to remember that all of that water has to go to the sea. And when the tide comes in, the door is shut at that point in time. Okay, so the water has to back up in the system somewhere. And we tend to get a lot more pollutants being carried off paved surfaces as well. And because we get much less infiltration, then we get much less water being naturally filtered, and we get much less groundwater as well. The Republic of Ireland, I'm not clear on the figures for Northern Ireland, but we're a bit of an outlier in Europe in that in terms of our drinking water supplies, we are very heavily reliant on surface waters. We use rivers and lakes quite a lot. Across Europe, they would use a lot more groundwater sources. I'm not sure in terms of the UK what the figures are, but what they found across Europe is because they have done so much land drainage, and because the weather patterns have changed and you're getting much more intense rainfall, so you're getting a lot of rainfall falling over a shorter period of time, it's actually been carried very, very quickly into drainage systems and out to sea. So you're getting much less infiltration. So we're starting to see our groundwater aquifers starting to drop. And there's also, they're getting less infiltration because they're using quite a lot of heavy agricultural machinery on land, and it causes compaction of the soil, so you just don't get that infiltration. So there's a lot of projects ongoing now in Europe looking at that and how they're going to have to reverse some of the engineering that they've done to try and take water away more quickly. They're going to have to reverse some of that because it's actually impacting the amount of groundwater that are available for drinking water supplies. Okay, so when we have that type of water that's running off, it's called stormwater. Stormwater is the rain that's collected on roads, roofs, paths, and other sealed surfaces. Okay, so look, a lot of water cycle problems, you've probably seen some of these before. Pollution is one of them. Okay, so you get contamination coming off. The other second one is waterway flushing. Okay, so where you get high volumes of stormwater, and that's becoming increasingly more significant now with changes in our weather patterns. Okay, so it can cause what they call a scouring effect. So if you get really large volumes of water coming down very, very quickly, you get populations of macroinvertebrates and other organisms, and you can have spawning areas for fish and that, and they actually get scoured out in that volume of water. It's like a power washer, and it just strips everything off the bed of the river or going into the lake at that point, and that damages the habitat for aquatic animals. It obviously as well alters the natural flood cycle, and you get eroding stream banks as a result as well. Okay. You get flooding, and we've all seen flooding happening. This is actually down in Douglas and Cork. And we've seen flooding caused in areas that are not necessarily close to waterways. Okay, so people talk about areas that never flooded before. This area never flooded before. But of course, that's because we've removed a lot of the natural floodplains. We've built on the natural floodplains. The water still has to go somewhere. So arterial drainage systems, digging out the river, it actually doesn't improve the problem. What it'll do is it'll take water away from the section of river at that point, but it just brings the water faster to the next section of river. So, all of those engineering solutions have really come to their limit now with our changes in our weather patterns. And you also get decreased soil moisture because the water actually doesn't get a chance to soak into the ground. And then you don't get healthy plant growth. You don't get trees tend to develop shallow root systems. And then a lot of those shallow rooted trees then tend to be more unstable and more likely to form in stormy weather, and then you get soil erosion into rivers, causing problems for water quality as well. So for that, we're looking at a lot of more kind of sustainable urban water cycle, and the likes of the Inishowen River Trust are actively involved in these types of nature-based solutions. I think you mentioned, Emma, in terms of plant life can filter. So you're looking at wastewater reuse or reduced wastewater discharge, or better infiltration. So you're looking at what they call sponge cities. So where there's a network under the ground, under our cities, which actually hold onto the water and then naturally release that quite slowly over time. And that tends to be done through plant-based systems like reed bed systems or swales, or other nature-based solutions where we're actually going to hold on to flood water in this area, then we're going to naturally release it, but we're going to remove a lot of the contaminants while we do that. So just in terms of the Irish River Basin District, and this relates to the Republic of Ireland, there's a total area of 70,000 square kilometres. Okay, so there's 46 catchment areas, 4,829 water bodies. And really to start addressing our water quality issues, we need integrated thinking. Okay, so we're going to have water scarcity due to unsustainable use, sectoral thinking, mismanagement, absence of water governance. Okay, then you get water scarcity, you get water-related diseases, food crisis. Okay, and we've seen that in areas where we've had issues around food crops, and then that leads to fodder shortages and other problems. Okay, we end up with degraded environments and natural hazards as a result. And of course, poor people are particularly affected, and that's what we've started to see with climate change, where the poorest people in the world are having are seeing the biggest impact. But I suppose what we've really started to see over the last 10 years is that wealthier countries are also starting to now be very severely impacted. Okay, so we've seen the droughts across Europe, the drying of very large rivers, across continental Europe as well. So it's really starting to come. I suppose it's starting to really arrive on our own doorsteps now, so we can really see the impact of it. Just a little piece around the Water Framework Directive. Okay, it was passed in 2000. I suppose it's important to say that it has been described as one of the most significant and ambitious pieces of water quality legislation globally. It's one of the most important pieces. And the reason for that is it actually takes an integrated approach to water quality. You're not just looking at rivers and then lakes and groundwaters. It actually integrates all of that together. Objectives is to prevent deterioration in status of surface waters, groundwaters, and water-dependent ecosystems, and to restore polluted water bodies to at least good status, okay, and to retain high and good status where they exist. But the most significant part is it looks at all of the water bodies, your rivers, your lakes, your coastal, transitional waters, your estuaries, your brackish waters. There's a special sub-programme for protected areas. We probably all know of special areas of conservation or special protected areas under the birds directive or the habitats directive in the UK. I think you have areas of special scientific interest, and you would also have had areas designated under the birds and habitats direction. The Water Framework Directive also has protected areas. There's 100 in Ireland now. There's 140 designated bathing waters. This from 2015, 64 shellfish waters, and then there is also 358 water-dependent SACs. Okay, so the Water Framework Directive also looked and said, well, there's special areas of conservation, but it's particularly important that they're protected under the Water Framework Directive because the species that are protected in those areas are dependent on water quality. So it was really one of the first times that water quality was linked to protection of aquatic species. Okay, and also artificially and heavily modified water bodies are included, and there's been some controversy around designation of some of those. Okay, so just for Ireland in terms of the 220 water quality indicators, okay, so we're looking at about 56% of our lakes are in good water quality, about half, okay, and about 30% of lakes have unsatisfactory total phosphorus concentrations, okay, so about half of them, the issue there is phosphorus. Rivers, we're looking at 47% have unsatisfactory nitrate. 38% have increasing nitrate concentrations, and that's a problem that we've started to is really coming to the fore now. 24% of sites have increasing phosphorus concentrations, and 29% of them overall have unsatisfactory phosphate concentration. What's interesting about phosphate and nitrate is most of the problems in nitrate tend to be happening, and they're concentrated around the southeast and southern part of the country. It doesn't mean that there isn't nitrate problems in other areas, but that's where most of the problems are, and that's where we see the best of land in the country, very free draining, very good quality land, because phosphorus and nitrate have different pathways when they move from land to water, and that's really important when you're looking at putting in solutions. So Emma, you mentioned, I suppose, using plants or that, you need to know what pollutant it is that you're trying to intercept so that you can design the correct solution to intercept it. Okay, so nitrate moves through the soil and down into groundwaters, or also where you've kind of got karst areas, so you've got an interaction between surface waters and groundwaters, you'll find nitrates there. Phosphorus then tends to move over land, okay, much heavier soils, kind of soils we'd see in the west of Ireland, more so you've got heavier clay soils, and it tends to move across the surface of the soil in that way. So 89% have satisfactory BOD values. That's a measure of organic pollution. 43% of our rivers have unsatisfactory biological quality. So those are our macroinvertebrates. That's our biological life that lives there. Groundwater is faring a lot better, to be fair, than rivers and lakes, probably because we can't get to them as easily, I'm sure. 24% have high nitrate concentrations, okay, which is greater than 25 milligrams. And then when we look at estuarine and coastal waters, 26% increase in loads of nitrogen, and nitrogen is the limiting nutrient for eutrophication in coastal waters. Okay, so when we start to look at our oceans, so phosphorus is the big issue for fresh waters. Nitrate is also a problem, but phosphorus is what tends to cause the algal blooms. When you start looking at it coastal environments, then nitrate tends to be the bigger driver there. And then you've also got a 35% increase in loads of phosphorus as well. The Environmental Protection Agency here produce an indicators report every year. So they've started to do that in the last number of years in order to, I suppose, to start looking at the data that's coming in. There's an awful lot of data coming in, and to actually see the trends. The Water Framework Directive actually operates on 6-year cycles, but 6-year cycles, it's too long. It's too long to be looking at water quality, in terms of the trends every 6 years. So they produce these really good water quality indicators reports every year. I'm sorry, I can't tell you what they're doing in the UK because I don't know in terms of, but I'm sure they must have similar reporting where they're doing it on an annual or biannual basis. So the total number of water bodies, as I mentioned, was 4,842, and 1,603 of those are at risk. Another 1,256 are currently in review, and they're going to require ongoing protection. And there's almost 2,000 of them, just a bit less than half, are not at risk. Okay, and you can see there, rivers, lakes, coastal and transitional waters, those are the three that are particularly impacted. Groundwaters are doing not too badly at all, and neither are our canals. Okay, when you look at the map and the water bodies that are at risk of not meeting surface waters objectives, you can see they're scattered throughout the country. Okay, there's no particular area, they're everywhere. Just a little bit then talking about monitoring under the Water Framework Directive. So there's just a nice diagram here up at the top right, and it shows you all the different components of monitoring under the Water Framework Directive. So, and the Water Framework Directive describes all of these as quality elements. Okay, so the macroinvertebrates is a quality element. They're the little organisms that live on the river bed. Macrophytes are your plant life. Hydromorphology is the it is the structure of the river. So it's the river banks, the bed, and they look at that and they assess it in terms of how natural it is or how much it's been modified. And these are all taken into account. So you can look at one aspect of the Water Framework Directive. So you can say, oh, the macroinvertebrates, and we've done a kick sample of the river, and they're all really healthy and really nice. That doesn't mean so. It can so a water body can meet one component, so it could meet the macroinvertebrates component, but if it fails, some other component, then that pulls it down in terms of the Water Framework Directive. It has to meet all of the quality elements. So it's important that you look at it in a whole and not just one component. Okay, so biological quality elements are phytoplankton, other aquatic flora, benthic invertebrates, and fish. They do fish surveys. The general components then, which are physiochemical elements, things like oxygen, nitrate, phosphate, ammonia, things like that. Then there are listed pollutants, so they are under Annex 8. They're kind of pesticides and some metals, okay, priority pollutants. And then the hydromorphological elements, and they're kind of water flows and physical characteristics of the banks of the river, the bed of the river, the meanders, all of those things, that natural. So all of those come together. So it's quite complex in terms of coming up with a water quality status under the Water Framework Directive. You're not just looking at one thing. It's multi-elemented. Okay, it supports the river basin management plans. That's how they're implemented. Okay, the Water Framework Directive is implemented via these river basin management plans under 6-year cycles. Okay, we're currently in the third and final cycle. So under the Water Framework Directive, we're supposed to have seen a restoration of water quality across Europe by 2027. It's very unlikely that that's going to be met at this stage. Okay, the Water Framework Directive then requires that you have to put measures in place to reduce or eliminate inputs of a polluting substance if you fail to reach good status. So if the monitoring is done, you can see here up in the diagram, if it's moderate, bad or poor, then the relevant authority, which in Ireland is the local authorities under the LawPro programme, they put measures in place then to improve water quality. And there's a lot of work goes into that. They very much refer to it as the right measure in the right place. So you have to be able to identify what the pollutants are, and then you have to match the measure that you're going to use to tackle that pollutant. And of course, that can be relatively simple if you're looking at one pressure on a water body, or one problem. But where you have, multiple different problems occurring, that's where measures can be quite complex in terms of putting those in place to address all of those issues. So as I said, you have all of the different quality elements. And if one of the quality elements, so if the fish element is poor, but the macroinvertebrates are good and the water quality is good, under the Water Framework Directive, they refer to this as one out, all out principle. Okay, so it actually pulls the whole thing down. So most of the others can be good, but if you've one bad, it pulls it all down in terms of status. And I suppose that can be, that can be quite, I suppose, in terms of seeing improvements then in water bodies, it can take quite a while to see the measures that have been put in place to see overall improvements in water quality where you have areas that have multiple pressures. So you may eliminate, a pressure caused by agriculture or a pressure caused by wastewater or hydromorphological where there was drainage works or something like that. But it can take quite a long period of time to see the recovery in that water body then. I've just included this slide again. It just kind of helps people if they're looking at some of the data around the surface water status. So what goes into actually your surface water status. So whether it's high, good, moderate, poor, or bad. Okay, so that's kind of what you're looking at. When you're looking at high, you're looking at reference sites there, ecological status good. There's kind of slight deviation from the natural environment, moderate, major, then there's major deviation, and severe then is really poor. So these are just some of the typical chemical parameters that are monitored in rivers. So when people talk about kind of water quality and monitoring, you also need to know the type of water body that you're monitoring, because it's different for different water bodies. So things like dissolved oxygen, conductivity, temperature, pH, dissolved oxygen there again, it's in milligrams per litre, and up here it's in percentage saturation. So that's 100%. And it's a much better value actually for people to look at if they're looking at dissolved oxygen values, percentage saturation, because milligrams per litre is influenced by the temperature of the water. So you'll see higher milligrams per litre in the same water body in winter than you will in summer, but it might actually have the same percentage of saturation overall. So it might be 90% saturated at both times of year, but you look at one, you'll go, oh my goodness, you know, the dissolved oxygen has changed, but in fact, it's actually the temperature that has changed. Those are quite simple parameters. They can be monitored using handheld meters, not particularly expensive, and they tend to be measured on the spot. So they tend to be measured in the water body there and then, and they give you values in the river. Okay, calibrated before you go out. They give you values there. Things then like alkalinity. Alkalinity is the ability of a water body to resist change in pH. So you'll tend to find rivers that run through chalk areas have very high alkalinity because they've got lots of dissolved alkalinity in the system. Rivers then that run through peat or fen areas tend to have low alkalinity. Okay, so alkalinity and pH are related, but they are not the same thing. Okay, so you can have a water body that has the same pH, and if one has low alkalinity and the other one has high alkalinity, you'll find that the one with low alkalinity may be more impacted if a discharge is discharged into that river. Chloride is another one. Nitrite, chloride is salt. I'm not sure in terms of the UK, it's becoming a particular problem in the United States. Okay, United States and Canada, they have very severe winters. They've been salting roads for decades and decades, and they're really starting to see an issue now with chlorides and salts in the water as a result of that. So big impact on fish, big impact on aquatic life in general. We don't, certainly in the west of Ireland, we don't tend to have those types of very hard winters. I mean, probably in Scotland, they would have, a degree of snow, but certainly really coming to the fore now in the last 10 years in the United States as being a significant problem. Nitrite, it is part of the nitrogen cycle, so nitrate and ammonia. These ones, orthophosphate, again, plant nutrient associated with algal blooms. Ammonia, particularly problematic for fish. Okay, it's toxic to fish. So where you have high ammonia discharges, you will have impact on fish. Tends to be regulated for on discharges, so whether that's industrial discharges or wastewater discharges in areas with salmonids particularly. Okay, if you've got salmon and trout fisheries, they will regulate for ammonia in particular. And then nitrate is the other one. So these ones that are here in blue then, you generally find that you can buy citizen science type kits for these types of parameters. So, you can buy them as kind of test strips or test kits and monitor those in that way. So if anybody gets involved in any of the water blitzes and I'm sure there's similar initiatives in the UK where, they'll have a day where they'll monitor water quality all over the country, and they tend to have these types of kits available for these types of parameters. Okay, alkalinity wouldn't typically be monitored on a lot of those kind of citizen science projects, but things like nitrates, phosphates, all of those tend to form parts of those kits. Lakes then, again, some of the parameters are similar, others are different, looking at things like chlorophyll, and transparency is another big one for lakes, and silica as well. So again, you need to know the type of water that you're the water bodies that you're monitoring, because that tends to determine the types of parameters that you're going to look at. So just in terms of the Republic of Ireland, then just the agencies that are involved in it. So the Environmental Protection Agency are involved, the local authorities, the Marine Institute, the Fisheries Board, Waterways Ireland, the Office of Public Works, and the National Parks and Wildlife Service are all involved in monitoring under the Water Framework Directive. So it's a real multi-agency approach, and that's because there's so many aspects in terms of the water bodies that are being monitored. Okay, so anyone any questions on that kind of piece around the Water Framework Directive? And I'll go into, like, people probably have specific areas that they want to talk about, and we can talk about that at the end of the slides. But if there's just anything kind of on the Water Framework, that directive, or that type of surface water monitoring, so whether it's lakes, rivers, that people have any questions on.
Have you got any advice on calibration of water quality instruments?
Yeah,
like citizen science kits and all that kind of stuff?
Yeah, I mean, there's been some work done actually on citizen science data, and there was a very interesting project done in Germany where they did quite they collected quite a lot of citizen science data, and then they also, when they were doing that, split some of the samples and sent them to accredited laboratories, and they found quite good correlation between both. And it's probably something, if you're looking at doing something on a longer term basis, it's probably something that's good to do early on, where, when you're looking for funding for these projects, that you put in for the fact that, okay, well, we want to split, we're planning on sampling once a month for 24 months or whatever the time period is, or maybe it'll be every week for 6 months. So we're going to split, 20% of those samples or 30% of those samples or whatever it is with an accredited laboratory, so that we know early on if we've problems, and if we've problems, well, what are the parameters that we've problems with? Because you may not find that there's issues with all of them, and there may just be issues with some of them. All of those citizen science kits anyway will have a kind of an uncertainty associated with them. So they'll say, it'll be plus or minus 10% or plus or minus 20%. So really, it's, well, is my monitoring, within that area. For things like meters and that, you can buy standard solutions for those, and you calibrate those then with the standard solutions before you go out, and they're quite straightforward. But that kind of would be my advice around that. Kind of before you start monitoring, kind of do a pilot test, split a sample, send it off, and see, are the results coming in around the levels that you would expect? They'd be much tighter. Standards around those type of independent laboratories. But is it falling in the area that you'd be expecting for those type of citizen science kits? And if it is, then at least you kind of have that confidence to progress with the monitoring program, and then split them, so that you can say, well, we've done this, we've sent so many samples away, and we know that that the accuracy of our data is good.
Oh yeah, very good. Thank you.
Yeah, no problem.
Lisa, can I ask about dissolved oxygen?
Yes.
That, like, there's a range that you're trying to get it within this range, like 80 to 100%, 120%. Does that apply to both rivers and lakes, or would you view lakes differently?
Yeah, I mean, a lot of it really comes down to the species that you're trying to support in those water bodies. Okay, so if you're looking at salmonids and those types of high status species, so even we'll say when you're starting to look at macroinvertebrates, if you're starting to look like mayflies, stoneflies, those types of organisms need good oxygen levels. One of the challenges for lakes is that diurnal variation. So you get higher oxygen in the daytime, and then it falls at nighttime. So and really for that type of monitoring, I suppose just to explain, you have plants in lakes. So you have photosynthesis happening. So for lakes, very often what you look at is you look at continuous monitoring. So you look at continuous monitoring for dissolved oxygen over 24 hours. So you can see how low is it going, because you go out there at 10 o'clock in the morning and it's telling you that it's 80% or 90%. And yet, you know, at 4 o'clock in the morning, that could be down at 40% or 50%. And you're wondering where your problem is with dissolved oxygen, or is it a factor in what's happening? So it kind of does depend on the water body. And again, you know, some rivers have very good, you know, just in terms of the topography, where, you know, they've got falls or natural falls now in the river, where you're getting oxygen being incorporated into the water naturally, you know. And lakes don't do that unless they have, you know, rivers coming into them. And that's why input of nutrients is so problematic in lakes, because they're like a big bowl. And there's really nowhere for it to go once it goes in there. So it tends to sit in the sediment. And then when you get storm events or heavy winds or that, it can become resuspended. And that can be a problem for the dissolved oxygen then, because you're I suppose you're moving this matter back up to the water column, and you have natural populations of bacteria in the water, and they will feed on that organic matter if it becomes resuspended, and they'll use up oxygen while they're doing that. So definitely for lakes, 24-hour monitoring. So you'll see this curve is much more preferable than just kind of spotlight sampling.
Yeah, that's brilliant. Thanks, Lisa.
Yeah, no problem. Okay, I'm going to move on to bathing waters. Caroline, you mentioned there was somebody looking at bathing water monitoring. So just a small piece around bathing water monitoring. So transitional coastal waters are covered under the Water Framework Directive. And then there's a separate piece of monitoring around bathing waters. It's carried out only during the bathing water season. And again, I'm talking about the Republic of Ireland here. So it's fortnightly from the end of May to mid-September is considered the bathing season. So if the heat wave comes in April, I'm afraid it's tough luck. That is outside of the bathing season. Okay, so 1st of June to 15th of September every year. So generally they'll do some monitoring before the bathing season opens. And then it's done every fortnight from then on. Okay, so water's classified as excellent, good, sufficient, or poor, and the information is available on beaches.ie. Okay, generally the information is available within 48 hours of monitoring having taken place. Okay, also available on X or Twitter or whatever it's calling itself these days. I suppose swimming has very much become a year-round activity. So there's a national bathing water expert group are now looking at protecting bathers' health outside of the bathing season. So they're really starting to look at that. A lot of interesting research around bathing water monitoring and tides and the way water is moving in terms of rivers coming in and where they come in. So bathing water monitoring can be quite complex, actually, depending on what the inputs are into the bathing area. The regulations from 2008, what you're monitoring in the bathing water monitoring is intestinal enterococci and also E. coli. Okay, so they are both microbes that the bacteria that live in the gut of warm-blooded animals. Okay, so they're both animal and human. Because they live in our guts, they're shed in feces, and they're found in both feces of both animal and humans. Okay, we monitor for enterococci and E. coli as indicator organisms. Okay, so we monitor for those, and that doesn't mean to say that there aren't other viruses or other things there. Okay, so indicator organisms are often used for microbiological monitoring because they're an indicator for the presence of feces, but they don't cause disease in the people who are culturing them in the laboratory. So that's one of the big reasons why they're chosen. Results then are published on beaches.ie within 48 hours of sampling. Okay, 4 classes: excellent, good, sufficient, and poor. So interestingly, our bathing water has continued to improve. Okay, so we've seen problems around our coastal waters and that with nitrates, but in terms of bathing water, remember when we're looking at bathing water monitoring, we're only looking at two parameters. We're only looking at the micro. Okay, and the reason why those are focused upon in terms of bathing water is because that's what's likely to make you sick. Okay, so really it's a public health measure in terms of bathing waters. It's not in terms of, you know, tracking water quality in the same way as you're looking at water framework directive monitoring. Okay, so 97% of the bathing waters met or exceeded the minimum required standards. And 3 bathing waters report Balbriggan, Ladies Bay in Buncrana and Tránamán in Anspidale. Okay, so again, you know, they tend to have particular pressures in those areas, very often urban wastewater when you look at or agricultural pressures. Okay, there was 34 bathing water incidents in 2022 and they resulted in beach closures, and then 186 prior warning notices. So prior warning notices are issued when heavy rainfall is forecast. Okay, so that's what we're really starting to see with this change in our weather. Heavy rainfall is forecast, and local authorities will put up a prior warning notice saying, we recommend you don't swim at these designated beaches for the next 48 hours. It's generally 48 hours afterwards. Interestingly, there's been 186 of them in 2022, which was 82 more than in 2021. Okay, and we had a particularly wet summer. So, you know, it's really starting to show, you know, the impact of that change in our weather conditions. Around 40% of those prior warnings were actually reported in the last 2 weeks of the bathing season. So that's the 1st to the 15th of September. And there was very high levels of rainfall at that time. So when we start to see that in bathing waters and there's monitoring in bathing waters, you know, then, you know, we can certainly assume that that's what's happening in other surface waters as well. Okay, because it's making its way down the river catchment and into the bathing waters. Okay, so it has to travel through our rivers, lakes, and wherever it's going to get to the sea. So if we're picking it up in the sea, then we can, you know, we can be sure that it's happening there as well. Okay, so main pressure on bathing waters, single-use plastics. They're everywhere. If you do beach cleanup, that's what you're going to be picking up, is all of this kind of thing. Urban storm runoff, so urban areas where we're getting storms, sewage and urban wastewater discharges, and emergency overflows. So emergency overflows happen if there's a breakdown in a piece of equipment at a wastewater treatment plant. Okay, and the EPA have said that Irish Water need to improve the operation, management and maintenance of treatment plants and networks which impact on bathing waters. Fouling from dogs and beaches was also a pressure. Stormwater discharges, so that's where you're getting storm events. So for a wastewater treatment plant, they're typically designed to take what is called 3 times dry weather flow, and it can be up to 5 times dry weather flow. Once there's any more coming into the system than that, then it will discharge into what are called these stormwater overflows. We often have combined systems, particularly in old towns and cities. So our surface waters, so the water coming off our roofs goes into the sewer system, as does the sewage. And then it's quite easy during these very intense rainfall events to get 3 times dry weather flow or 5 times dry weather flow. And then what we have is we'll have screened sewage then being discharged at that point. It's obviously highly diluted because you've got an awful lot of water coming through with it, but it still contains pollutants. Okay. We also have what they call freshwater storm flows and runoff. So that's where you have runoff from rural areas and agricultural areas into rivers that then bring all that down to the beach. Okay. The EPA have advised that local authorities need to prioritise measures to improve the 2 poor bathing waters and to increase the number of bathing waters to good or excellent. Okay, so I mean, we would have seen that last summer where we had this just a clip from the Irish Times where they had water quality warnings at more than 30 beaches and lakes after heavy rain and swimming bans in areas. So, you know, there's an impact from us as local people living there, but there's also an impact for tourism. So, you know, these water quality pressures are starting to I suppose the more monitoring we're doing, the more we're seeing with the changes in weather pattern, particularly with those intense heavy rainfall events, we're starting to see more problems presenting in our surface water than our bathing waters. I suppose just an interesting piece around formally identifying bathing waters. The bathing waters that are monitored under the bathing water legislation must be designated bathing waters. So, you know, you'll have areas that are not kind of formally identified as bathing waters, but people are swimming there. And particularly with this increase in sea swimming and people swimming a lot more. But any person or a community body can request of a local authority that an inland or coastal water used for bathing should be formally identified. So if there's an area that people go and swim in, or that you use for swimming, or your kids swim in, or your neighbours do, or whatever, you can formally request that that be included. Okay. Now it has to meet the relevant criteria for classification as a bathing water, and I've just put up a link to that there, and you can find out where that is. But I mean, there's inland areas at lakes and you know, on the banks of some of the larger rivers, for shore, for example, where they are designated bathing waters. If they're designated bathing waters, then it means they're monitored. And if there are problems then in that area, they're much more likely to be addressed because you have the data. You know, so it can highlight you know, can highlight problematic areas. So it's just people are often aren't aware of that. I think it's usually maybe around May or June every year that comes out, and it's the local authorities will open a window where you can request a bathing water area to be designated. Okay, so any questions on the bathing waters?
No, so thank you for that, Lisa. I think it was the TY group from Buncrana who are doing a project specifically on Ladies Bay, you know, being designated per. So I know that they'll be listening to the recording, so I'll point out that bathing water. Thank you for including that.
Yeah, no problem at all. Okay, so just a little piece here on citizen science, and I've quite a lot of slides here. I'm not going to go through them all, but it's really just for information for people on them. Okay, so citizen science, you're probably aware of this, is the practice of public participation and collaboration in scientific research. Okay, so Law Pro are the local authorities waters programme. They are the group in Ireland that are responsible well, one of the key groups are responsible for implementing the Water Framework Directive under the River Basin Management Plans, and they identified that in the second cycle of the River Basin Management Plans, the importance of involving people. So for the first cycle and into the second cycle, there was very much a top-down approach. Okay, so the regulating agencies and bodies were out doing the water monitoring and doing all of that and doing the assessments. And you know, that was very much identified as being quite a limited approach in the second cycle. So there was a much greater emphasis into the second and third cycle around active participation in by citizens. Okay, and you see these Law Pro funded projects where you can apply for funding, and they have community water officers, you know, who will engage with groups and that as well. And they found that it engages people, it involves the public in the monitoring of rivers, so it increases local knowledge and it increases the potential for data. And it also acts as a source of local knowledge as well, which is really valuable. They've developed this citizen science stream index, which you've been using in Inishowen, Caroline, and it's suitable for beginners. Really nice. It's just quite simple, but really, really nice index. And there's also a small stream impact score then, and that's used by scientists for more advanced practitioners. So people who've been doing a good bit of this type of monitoring. Really simple, really easy, and anyone can do it. And you classify your water body, and it's got your traffic light system, and then you can take a photograph and they will check and verify your sample as well, which is, you know, really, really useful. So there's a recording sheet for that, and you know, school groups have done it. I'm sure you've probably had quite a lot of groups, Caroline, who've used it.
Yeah, and we've done it with group. Sean and I were out with a third and fourth class, that's 9 and 10-year-olds, just in September or October, was it, for Wainfest, doing that. And it does, I mean, they do love the sort of getting down on their hands and knees and kind of like, you know, taking a look at this small, trying to identify the small invertebrates. yeah, so it's a good engagement exercise.
Yeah, yeah, and you don't have to be a rocket scientist to do it, you know, and by doing it a few times, you get quite familiar with them. You're not going to be, you know, identifying them that down, you know, terribly far, but you know what stoneflies look, you know what mayflies look like, you know what and it's really useful. So this is biological monitoring. So as I was saying, you can get the citizen science kits for measuring your pH, turbidity, all those other things. And then you can also combine it with this and it gives you a much better picture. The one advantage of this type of biological monitoring is the organisms that live in the water body are there all the time. Okay, they're the long-term residents, all right. So the presence or absence of those gives you a lot of information, not just about water quality, because sometimes the water quality can be very good, but the high quality species, okay, the good ones, I think are they called the goodies and the baddies or something in this scoring system. But the good ones may not be there, and it may not be a water quality issue, but it may be what they call a hydromorphology issue. So there may not be a suitable substrate there anymore. Okay, so maybe the riverbed was dredged and they took all of that substrate out, so all that's left is mud at the bottom. Okay, these types of macroinvertebrates won't live in that type of environment. You know, it's similar for fish and other species. You know, if the spawning area isn't there, then you're not going to have the fish coming the next year. So again, it's similar for these, and it gives you, so the water quality gives you a piece of the picture, and then you start looking at macroinvertebrates, and that gives you another piece of the picture. And then, as Emma was talking about the plants, then you look at the plants in the area, and you can do habitat mapping to look, and that gives you another piece of the picture. And that's why those types of assessments that they do under the Water Framework Directive are actually quite complex, because you've got all of the different elements, and then you put all of that together to create a score. But these are really useful in terms of citizen science. And as I said, you don't have to be a rocket scientist to do it. They're good fun, and they give you a lot of information. Dublin City University do a water blitz every year. Were you involved in that this year in Inishowen, Caroline?
No, we weren't. We didn't. Trish,
Yeah.
Yeah, we were.
Oh,
Sorry, yeah. We've been doing it for the last few years, actually.
Yeah.
Lisa. So yeah, no, it's very good.
Yeah,
Very
it's a
good.
really good. So they do it every year. So once a year, they do a water blitz. So they try and get everybody to take water samples over the same few days. And there was 700 participants and 697 samples taken across the country. 82% of Irish water bodies were high or good quality water when tested for nitrates, while the equivalent figures for phosphates was 59%. Okay, so there's 108 community and water interest groups, which shows the level of interest in this area, you know. And 73% of participants believe that they have the power to improve or maintain good water quality through citizen science, you know. So, and I think, you know, there is that piece around, well, it's not really up to the EPA to do all of it for us. You know, there's 70,000 kilometres, and that's just in the Republic of Ireland, okay, square kilometres. There's 46 catchment areas. There's 4,829 water bodies. So, you know, there's no agency is going to mind all of that. So there's really an onus on all of us to be water stewards. But and 70% of participants felt that their contribution can help build greater understanding of water quality in Ireland. So I think that's really important, you know. It's a really nice initiative. There's a Crowdwater app. It's a smartphone app developed by the University of Zurich, and it's used by citizen scientists to monitor rivers throughout Europe. Crowdwater app is nice. You can upload a photograph of your river onto it, and you can put in all the coordinates, and there's kind of more projects linking into Crowdwater as well. So there was a flow and ecology project that was run out of ATU in Galway. They were collecting water this year, or not water, they were collecting water levels this year, and they were using the Crowdwater app. So it's just a way of uploading data. And I know that they were looking at that in terms of the citizen science initiative as well. So they were looking at, you know, ways in which people could, you know, upload their data and for long-term, for kind of storage and sharing of it. This is just from the EPA website. So what citizen science projects can I get involved in? So Dragonfly Ireland 2019 to 24, there was Explore Your Shore. There was also an air quality project, Reconnect then. And the Reconnect is a really interesting project for people who are interested in water quality, because one of the biggest problems that we have is barriers. So you have barriers in terms of fish trying to move back upriver, but also you have barriers in terms of water trying to get from upstream to downstream. And fish are not the only species that are moving, up and down. So rivers are linear systems, okay, and they're branching as well, because you have all of these tributaries coming into them also. So we have a lot of weirs and ponds and dikes and dams and all sorts of things that were constructed with a particular purpose in mind. So it may have been built for a mill. The mill could be gone for 150 years.
Yeah.
But the weirs are still there. So some of the infrastructure is still left in the river. And that's been identified as one of the biggest issues for water quality across Europe. And it's having a severe impact. And the building of hydroelectric dams is also that's very much to the fore now in terms of renewables. And they're starting to look at it. Well, is it really renewable because of the impact that it has on water quality? So we've had the first whole river kind of protected area in Europe. The Vijosa River flows through Greece and Albania, and it is the first river protected area in Europe. And it's free flowing from its source the whole way to sea. Okay, so yeah, there's very much an interest now on those rivers that haven't had artificial barriers put in place. So this Reconnect project, you can go on your river, you can identify the different types of barriers that are on it, and this is all across Europe. And you can there's other projects in other areas as well. You take a photograph of it, you upload the coordinates, and it helps them identify how many barriers, and that feeds into projects then where they're looking at removing barriers, because I suppose one of the big issues with addressing a problem is you can't address it until you know how big it is. And there's a lot of work goes into kind of going out and surveying rivers, and really very often the people who grew up beside that river know exactly where all of those things are, because they spent their childhood exploring all of those areas. So that Reconnect is a really nice project. And then of course there's reporting littering and dumping, that's kind of separate, but it is it's lots of kind of those kind of projects to get involved in it. People just want to dip their toes in and see
the Maid Rivers Trust last week mentioned freshwater app, which sends you out kits for phosphate and nitrates, I think.
Yes.
And then we did the big river watch with the Rivers Trust, the British Isles Rivers Trust. So for all Ireland, and then England, Scotland and Wales.
Yeah. So there's lots of initiatives happening. So if people are, interested, they can look at some of these, get their toes wet. That Reconnect is really nice, and then kind of say, "But I'd like to actually do more," and then get involved, as you said, in the freshwater app or the Big River Watch or that DCU Water Blitz every year. I'm going to finish up with this, and I'm not going to spend a huge amount of time on this. Just in terms of available resources, there's huge amounts of data out there, absolutely huge amounts of data. And a lot of it for the Republic of Ireland is available on the EPA Geo Portal. Okay, so there's a Geo Portal site. You can look at the maps, as you can see there on the right-hand side, or you can get data. It's all there. It's all freely available. It's there on bathing waters, air quality, water quality, integrated pollution and prevention and control license, historical mine waste, wastewater treatment plant licenses, certificates reporting around that, water framework protective areas, hydrometric stations. So hydrometric stations are the water level and the discharge. So what the flow in the river is, that's all there. And what I've actually done is I've just kind of said, if you go into the Geo Portal, for example, you could get significant pressures. What are the significant pressures on lakes or on rivers? there's loads of information. If you go into Water Framework Directive, or you can go into Water Quality and Monitoring is another one. And you can download data and look at that data. Okay, so that's on the EPA Geo Portal page. And they have fantastic maps that you can look at. You can look at your counties, you can look at chemical monitoring points, you can look at risk zones, you can look at, there's just so much area there. Phosphorus, water quality, what the ecological status of the rivers are. So those maps are really useful. They have special areas of conservation are in there. There's huge amounts of information all there on the mapping. Very easy to use. You just turn the filters on and off in terms of the layers. But really, really nice. And it really kind of brings that data to life, because you can actually see that water quality data and that other data over time there. They also have peatland maps, catchments.ie. Some of you've probably used this before. Really, really excellent resource. It's run by the Environmental Protection Agency. Huge amounts of information. The local assessments are on those. So there's the 583 subcatchments, the 46 catchments, and you'll find the reports on catchments.ie if you go in looking there. You can go into your area, go into your catchment and see what information is out there on it. So it's really, really useful. And the EPA made the decision to make all of this data publicly available, and it's there. It just needs a little bit of playing around. But the Environmental Protection Agency also have a guide if you go onto their GeoPortal website on how to use it. So that's really useful as well. Teagasc have some information on soils as well, because of course the soil type will determine very often the way pollutants move in the environment. There's the National Biodiversity Data Centre. Biodiversity maps and biodiversity information is there. National Parks and Wildlife Service have some really good maps and information on special areas of conservation. So there are special areas of conservation for water dependent species, so you can find those there, and some of those are also on the EPA GIS mapping as well. There's the Marine Data Centre and the Marine Irish Digital Atlas for marine data. GSI then have bedrock, groundwater, geological heritage and geotechnical information, which is in a cave database as well. And as I said, if you're looking for other information, catchments.ie do a newsletter, really, really good. Sign up to it. Lots of very interesting information on that. The Environmental Protection Agency website. I've just put up a thing here on drinking water parameters. We're not talking about drinking water tonight, but it kind of lists all the parameters that are monitored. And it's actually quite useful because it just gives a little short description of nitrate and its significance, or ammonia and its significance. It won't have all of them because it's particularly related to drinking water, but it has quite a lot. And there's also then the link there to the National River Monitoring Programme and the National Lake Monitoring Programme as well, if people want to find out about other parameters. So I suppose I'm certainly preaching to the converted here when I say, get involved in your area. So it's really important. I suppose there are water bodies at the end of the day. The agencies just help us mind them, but it really is it is up to us. And I think when they talk about the Water Framework Directive being really, really important piece of legislation, this quotation is actually from the Water Framework Directive. So water is not a commercial product like any other, but rather a heritage which must be protected, defended, and treated as such. And I think that really speaks to what the Water Framework Directive is trying to achieve. And as citizen scientists, we can play an active role in delivering the vision of that directive.